Good day, everyone. Today we are going to discuss graphing systems of linear inequalities in two variables. In this lesson, you will be acquainted with the application of systems of linear inequalities in two variables in solving problems related to life. The scope of this lesson enables you to use it in many different learning situations, and the lesson is arranged following the standard sequence of the course. So, after going through this module, you are all expected to define systems of linear inequalities in two variables, graph systems of linear inequalities in two variables, and solve problems involving systems of linear inequalities in two variables. Now let us start the lesson by considering this situation. One day, you are invited by a friend to accompany him to a math exhibit in their school. As you look at each display, there were three particular frames that caught your attention. So this is the first frame, the second frame, and the third frame. My questions for this situation are, what does the shaded region in each frame means? So the shaded region for frame 1, frame 2, and frame 3. Now the shaded regions tells us that these are the solutions for each linear inequality presented in each frame. Second question, how does the shaded regions in frames 1 and 2 differ from the shaded regions in frame 3? So the shaded region for frame 1 is this part, frame 2, and as you can see on frame 3, the shaded regions of frame 1 and 2 are combined. So we have here a much darker shade. So this is the difference of frame 1, frame 2, and frame 3. Now let us discover the content vocabulary for this lesson. So the set of all solutions to a linear inequality in two variables can be presented clearly in a Cartesian coordinate system by graphing. A system of linear inequalities in two variables consists of at least two linear inequalities. Solving systems of linear inequality means graphing each individual inequality, then finding the solution sets or group of points which satisfy all the given inequalities. The solution sets of a system of linear inequalities in two variables is located on the shaded region common in all inequalities. Now let's proceed to the steps in graphing systems of linear inequalities in two variables. So we have here step number 1. Rewrite each mathematical statement into slope-intercept form, which is y is equal to mx plus b, where m is the slope and b is the y-intercept. Note, whenever you multiply or divide an inequality by a negative number, you must reverse the inequality sign. Now, step 2, we have here graph the system of linear inequalities in two variables in a Cartesian coordinate plane. So we have here locate the y-intercept or the point 0 and b. It is the point where the graph crosses the y-axis. The second one, use broken lines for linear inequalities using less than and greater than, and solid lines for linear inequalities using less than or equal to and greater than or equal to. Now let's proceed to the next step. Shade the region above the graph of y is greater than or equal to mx plus b and y is greater than mx plus b, and shade the region below the graph of y is less than or equal to mx plus b or y is less than mx plus b. The next step is do the same steps in graphing the other given linear inequalities in two variables. Step number 3, observe the shaded regions. The area where the shaded regions overlapped is where the solutions of the system of linear inequalities are located. It means that all the points in that area make the system of linear inequalities in two variables true. Now let us apply the steps in the given examples. So I have here example number 1. Solve the system. Negative 3x plus y is less than negative 1 and 2/3 x plus y is greater than or equal to 2. Now let's proceed with the solution.
Now let us try to solve example number 1. The system of negative 3x plus y is less than to negative 1 and 2/3 x plus y is greater than or equal to positive 2. Now let's solve first this one. So step 1. We are to rewrite the inequality to slope intercept form. We have here negative 3x plus y is less than negative 1. So let's do the first inequality first. So transpose or transfer negative 3x to the other side. This will become positive 3x minus 1. So this is now our slope-intercept form, which gives us our slope as 3 and our y-intercept as negative 1. Step number 2, graph. Now we are going to graph this one. Two, 3, 4, 2, 3, 1, negative 2, negative 3, negative 4. This is negative 1, negative 2, and negative 3. Now, our slope-intercept here, our y-intercept here is negative 1. So we put the point here, and our slope is 3. A slope is our rise over run. This is where we determine kung asa ta mosaka, asa ta padulong. Now our rise is positive 3. Now you remember that all whole numbers has always a denominator of 1. So always ginay 1 basta whole number na siya denominator na 1. So our rise is positive 3. That means we are going up 3 times. 1, 2, 3. And this is our second point. Our run is 1 here. Okay, so we need to connect the 2. Our 2 here. This is our 1. Now remember, we are going to use broken line because our inequality here is less than. So we need to connect the 2 points with only a broken line. Now let's determine the solutions. Step number 3, determine the solutions, or the part where we are going to shade. So for above, we are going to choose negative 1 and 1. For below, we are going to choose 2 and -1. Using the same for the given inequality, we are going to substitute our ordered pairs, our test points. So that is -3x plus y is less than -1. You substitute the values of x and y. This is 3 plus 1. This is 4 is less than -1, which is always false. For the other side, we have here 2 plus -1 is than -1, -6, -1 is less than -1, -7 is less than -1, and this is true. Meaning, our solution is the area below the line. So this is our shaded part. Now let's solve for the second inequality. We have here 2/3 x plus y is greater than or equal to 2. Now rewrite the inequality to slope-intercept form, transferring 2/3 x to the other side. From positive, that will become negative. So this is y is greater than or equal to -2/3 x plus 2. Giving our slope as -2/3 and our y-intercept as +2. Now let's graph this one. Let me change. Okay, so our y-intercept here is 2. So we need to plot 2 here. And our rise is negative, this one. So we need to go down 2 points, 1, 2. And our run is +3, 1, 2, 3. Now we already have the 2 points. We need to connect this using a solid line because our inequality is greater than or equal to. So we are going to connect this. Now let's determine the solutions. Our above is, let me choose +2 and 2. And our below is -1 and 1. -1 and -1. Using given inequality, we have here 2/3 x plus y is greater than or equal to 2. Substitute the given values. It's 4/3 plus 2 is greater than 2. This will become 4. This is 3. This is 4 plus 6 is 10 over 3 is greater than or equal to 2. And this is 10 divided by 3. This is 3. 9. This is 3.33 is greater than or equal to 2, which means this is true. For the below part, let's solve this one. 2/3 x. Our x here is negative 1 plus negative 1 is greater than or equal to 2. This is negative 2 over 3 minus 1 is greater than or equal to 2. This will become 3, negative 2. This is clearly false. So our solution is the above. So we need to shade the above part. So this is the solution. Now, in combining this one, we are going to, for step 4, combine the two graphs. So we have the first graph we have here, passing the points 1, 2, and negative 1. So our points here for graph number 1, we have 1, 2, and negative 1. So the first point is here. The second point is here. Connect that using a broken line, because this is the graph for the first inequality. For the second graph, we have shaded this part. Let me use another color. Okay. For the second graph, we have here 2 and 3. 3 and 2. So we have here 3. We have here 2. We need to connect the 2 points. The shaded region for the second graph is the above. So this part here. Okay. Now since you have the graph, let's proceed to step number 5. Step number 5. Select points that are located on the overlapped shaded regions. Meaning, diri ta mamili kung asa nag-overlap ang shade or asa nga part ang naay duha ka color sa shade. So for this one, I'm gonna choose here positive 3 and positive 3. I'm gonna select 2, 5, and 1. So we have test points. My first choice is positive 3 and positive 3. And the second choice is this one, positive 5 and 1. We are going to solve this to our system of linear inequalities. So we have here 3x, negative 3x rather, plus y is less than 1, and 2/3 x plus y is greater than or equal to 2. So the first one, so this will become negative 9 plus 3 is less than 1. 6/3 plus 3 is greater than or equal to 2. 9 plus 3, that's negative 6, less than 1. And this is true. 6 divided by 3, that is 2. Plus 3 is greater than or equal to 2. We have here negative 6 is less than 1. 5 is greater than or equal to 2, which makes the two inequalities true, meaning our answer or shaded region is correct. Now let's try for another test point using the same. 3x plus y is less than negative 1. 2/3 x plus y is greater than or equal to 2. So we have here 3 times 5 plus 1. 2/3 times 5 plus 1. This is greater than. So this will become 15 plus 1 is less than 1. 10/3 plus 1 is greater than or equal to 2. So this will become 16 less than 1. What happened? Our x is 5. Our y is 1. Yes. This is false. I see. Here's the problem. This is negative. That's why it's really important nga dili malipat sa signs. So this is negative 15. So the answer here is not 16. This is negative 14. So this makes true. And also the second one makes true. So here you go. This is now our graph. This one.
Let's have example number 2. Solve the system. 4x plus 2y is less than or equal to 8, and x minus 3y is greater than or equal to 9.
Okay, now let's solve example number 2, which is the system of 4x plus 2y is less than or equal to 8, and x minus 3y is greater than or equal to 9. So, step 1, again, rewrite each mathematical statement into slope-intercept form, that is y equals mx plus b, where m is the slope and b is the y-intercept. So, for step 1, rewrite to slope-intercept form. So we have here, the first one, we have 4x plus 2y is less than or equal to 8. Now this will become 2y is less than or equal to negative 4x plus 8. Now we need to divide 2 to both sides of the inequality. So we have here y is less than or equal to negative 2x plus 4. Because negative 4 divided by 2 is negative 2, 8 divided by 2 is 4. So this is now our first slope-intercept. The second one we have here, let's go back first to the first one. From this one, we are able to see that our slope is negative 2 and our y-intercept is 4. Now let's proceed to the second inequality. We have x minus 3y is greater than or equal to 9. And this will become, from positive x, this will become negative 3y is greater than or equal to 9. Let me change this one. Negative x plus 9. Now, as you can see, we have here negative 3. Since we are going to divide negative to both sides of the inequality, be sure to change the symbol in reverse mode. So this will become y is less than or equal to this is positive. Negative divided by negative is positive. That's 1/3 x minus 3. So our slope intercept form for the second inequality is this one. So we have the slope as 1/3 and our y-intercept as negative 3. Now let's proceed to step number 2. Step number 2, we are going to graph. Let us first graph the first inequality, which is this one, where our slope is negative 2 and our y-intercept is 4. So our first point, our y-intercept is 4 is here. Our slope is negative, so we are going down 1, 2, and our run is 1. Remember, m is equal to rise over run. And this is a whole number. It means na siya denominator na 1. Now, in connecting the points, we are going to use a solid line because of the inequality less than or equal to. So, we are going to connect this one. And for the graph of the second one, we have here the slope of m is equal to 1/3 and our y-intercept is -3. So the first point we have here, the y-intercept -3, and rise is 1, run is 3, 1, 2, 3. So this is the second point. We need to connect these two using a solid line because we are using the inequality symbol here, less than or equal to. Okay. Now let's determine the solutions for the two graphs. By using the test points. For the below and above. For this one here, I am going to use sa below 1 and 1 and sa above 3 and 4. 1 and 1, 3 and 4. For the second graph, the below is negative 4 and -3. And for the above, we are going to choose 2 and 2. Using the original inequalities, we have here 4x plus 2y is less than or equal to 8. For the second graph, we have here x minus 3y is greater than or equal to 9. So, substitute the values of x and y. So, this is 1 and 1. 4 plus 2 is less than or equal to 8. 6 is less than to 8. This is true. 4 times 3 plus 2 times 4 less than or equal to 8. 12 plus 8 less than 8. This is 20 is less than or equal to 8. This is false. Therefore, for our first graph, we are going to shade the below. So this is our solutions, this area. For the second graph, let's solve this one. This is 4 minus 3 times -3 greater than or equal to 9. 4 plus 9 is greater than or equal to 9. 13 is greater than or equal to 9. And this is true. Second one, we have 2 minus 3 times 2 greater than or equal to 9. This is 2 minus 6 is greater than or equal to 9. Negative 4 is greater than, which is false. For the second graph, we are going to shade the below part. So this is our solution. This one. Below the line. Below the line and on the line because we are using the solid line. Okay. Now, step number 3. Combine the graphs. So we have here, let me draw a big 4 and 3. One, two, three, 4. No, this is 1, 2, 3, 4. So for the first graph, let's plot that first. That is 4, 1 and 2. So here and here. For the second one, we have 3 and negative 2 here and negative 3. Let's extend this one. So this one also connect. For the shaded region, for graph number 1 is below. We have here for graph number 2, we also have below. Okay, now for the last step, we are going to check if the shaded region is correct. Okay, so we are going to focus on the double shaded region. Okay, this is step number 4. Check the double shaded region. We can only use one point from where it lies in the double shaded region. Kung dira isa, not necessarily duha, I will show you just one. Now for this case, I'm gonna use the point that is on the area here. So I'm gonna use positive 2 and negative 3 that is located here. So let's use positive 2 and negative 3. Now let's divide this into 2. We are going to use the two linear inequalities, which are 4x minus 2y is less than or equal to 8 and x minus 3y is greater than or equal to 9. Substitute the values of x and y. So this is 4 times 2 minus 2 times negative 3 equal to 8. 8 plus 6 less than or equal to 8. This is 14. This is false. Why is this false? Let me check. Let me check here. Why is this false? To a negative 3. This is where I am wrong. Nara. Careful, this is the second time. As you can see, this is plus. So, dapat mag-plus data dito to make the statement correct. So, this is 4x plus. So, this is negative 6. 8 minus 6 is 2. And this makes our statement true. So, again, careful jud nga dili ta masayop sa sign because sometimes those are the reason nga nung ma-zero ta or maglibog ta. So, this is now, we have shown that using one point in the double shaded region, diri dapit, we have proven in two systems we have proven in the system of linear inequalities 4x minus 2y is less than or equal to 8 and x minus 3y is greater than or equal to 9 that they are both true. So this makes the two linear inequalities true, and note that this point is just one of the many solutions to the given system of linear inequalities.
Now let's proceed to the steps in graphing the given system of linear inequalities where x is less than p and y is greater than or equal to q, where p and q could be any real number. So here is step number 1. To graph x is less than p, draw a vertical line crossing the x-axis through the point p and 0 and shade the right region if the inequality symbol is greater than, or shade the left region if the given symbol is less than. Step number 2. To graph y is greater or equal to q, draw a horizontal line crossing the y-axis through the point 0 and q, and shade the region above if the inequality symbol is greater than, or shade the region below if the given symbol is less than. Now let's proceed to step Number 3, observe the double shaded region of the graph of the systems of linear inequalities in two variables. This region contains all the ordered pairs that make both linear inequalities true. Now let's have an example for this kind of linear inequalities. So we have here sketch the graph of x is less than 2 and y is greater than or equal to negative 3. So step number 1, draw the vertical line passing the point 2 and 0 and shade the left region since we are using the less than symbol. Step number 2, draw the horizontal line passing through the point 0 and negative 3 and shade the above region. Above because we are using greater than or equal to symbol. Step number 3, the double shaded region of the graph contains all the ordered pairs that make both linear inequalities true. Thus, the set of all these ordered pairs is called the solution set of the given system of linear inequalities in two variables, which is x is less than 2 and y is greater than or equal to negative 3.
Okay, now let's try to graph system of linear inequalities that is in the form of x is less than p and y is greater than or equal to q. Now, these are the steps. This has already been discussed, but for further understanding, let us first do this example number 1. So we have here the system of x is less than 2 and y is greater than or equal to negative 3. For this one, we are going to graph the first inequality. We have here so we have 2, 3, 4, 1, 3, 4. Since in this part, given na si x is less than 2, we need to have our point. Let me put numbers first. Okay, so our point for x here is 2. So we need to point that one. And we need to use a broken line. We need to remember that we are to draw a vertical line crossing the x-axis through the point P and 0. So, crossing the x-axis, we are going to use a broken line. Why broken line? Because again, our inequality is less than. So, we are going to use broken line. The next step is to shade the right region if the inequality symbol is greater than. But since we are using less than, we are going to shade the left region because our inequality is less than. So the part where we are going to shade for the first inequality is this one. Now let's proceed to the second inequality. We have here y is greater than or equal to negative 3. So that means our next point is here, which is negative 3 of y. And we are going to draw a horizontal line crossing the y-axis through the point 0q. Okay, since we are going to draw a line crossing dira, we need to remember unsa atong gigamit nga inequality that is greater than or equal to. So we are going to use a solid line. Now, asa ta dapit mag-shade? Shade the region above if the inequality is greater than. Since we are using greater than, so we are going to shade the area above our second inequality. Let me use blue. So, this is the part where our shaded region overlap. Kana nga area ang nag-overlap. Now, in step 3, observe the double shaded region of the graph of the systems of linear inequalities in two variables. The region contains all the ordered pairs that make both linear inequalities true. Now, for that one, we can choose a test point. Mamili ta dire. We can choose a test point para ma-prove na to nga sakto to ang graph. Let's say negative 2 and 2 here. So we have negative 2 and 2. This is our x and this is our y. So using the inequalities, x is less than 2 and y is greater than negative 3. Simple. Ilisan lang si x and y. So here, we only have x. This is negative 2 is less than 2. This is very true. Now, for y, we have 2 is greater than or equal to negative 3. And this is also very true. Therefore, our graph is correct. So, this is how you do systems of linear inequalities showing these figures or in this form.
You have just learned how to solve systems of linear inequalities in two variables. Here is an activity that is for you to try on, but we are going to answer this one together. So we have here the instructions or the directions. Sketch the graph of the system of linear inequalities in two variables, which is the system of y is less than 2x plus 2 and 2x plus 4y is greater than or equal to 2. So step number 1, are the inequalities in the form y is equal to mx plus b? If yes, check the column, and if no, transform. So we have here the table. We have the linear inequalities y is less than 2x plus 2 and 2x plus 4y is greater than or equal to 2. Let's inspect this first. This one is already in the form y is equal to mx plus b. So we check yes. No need to transform because this is already in slope-intercept form. For the second inequality, we have here 2x plus 4y is greater than or equal to 2. This is not yet in slope-intercept form, so we check the no and we transform this one. How do we transform this one? You transfer 2 to the other side, transfer 2x, that will become negative 2x plus 2.
As promised, I am going to discuss nganong naing-ani ni siya from this. So let's begin. So from 2x, plus 4y is greater than or equal to 2, we are going to transform this into slope-intercept. So see, positive 2x will transfer to the other side, so that will become 4y is greater than or equal to negative 2x plus 2. Since you have 4 here, we need to divide that on both sides of the inequality. 4 divided by 4, that's y is greater than or equal to negative 2 divided by 4, that's negative 1 half. X plus 2 divided by 4 is 1 half. And this is why, this is the reason why nga nahimo siyang ingon ani. So this is the slope-intercept form, making our slope negative 1 half and our y-intercept as positive 1 half.
Step number 2, complete the table. Use your answers in step 1. So this is the table, and this is our first linear inequality in step 1. So we have here, we are going to identify the slope, rise, run, the y-intercept, and the type of line to be used. Now for this one, our M here is 2. Our rise is also 2. Now, since our M is our rise over run, you remember that any whole number has a denominator of 1. Since we have a whole number 2 here, our run is automatically 1. Since 2 divided by 1, the answer is 2. And our y-intercept is the last number or the constant, which is the b, and that is 2. The type of line to be used is a broken line since we are going to use the symbol less than. So that is broken. The second inequality that we have is y is greater than or equal to negative 1 half x plus 1 half. Our slope here is this one, the negative 1 half. Our rise is negative 1, and our run, the one below or the denominator, is 2, and our y-intercept is the positive 1 half. Now, for the type of line to be used, we are going to use the solid line because we are using greater than or equal inequality symbol. Step number 3, graph and then shade the region. And for the last step, give 2 points in the double shaded region which satisfy the given inequalities. This step is just for the checking or validation of your graph.
For step number 3, graph then shade the region. Now this is what we are going to use. This was given in the previous slide. So let's graph first, the first one. So we have here so first we have our y-intercept is 2. So our y-intercept is 2. This is here. And our rise is positive 2. We need to extend this one. Now our rise, going back here, the y-intercept is 2. Rise is 2, 1, 2, and our run is 1. So this is our points. We are going to connect that using a broken line because of our inequality symbol, which is less than. Okay. Now for the second one, our y-intercept is 1 half, positive 1 half. So that is in here. And our rise is negative 1 going down. So here. And our run is 2. 1, 2. So this is the second point. Connect this using a solid line because of our inequality. So we have now the graph. Step number 4, give 2 points in the double shaded region which satisfy the inequalities. Okay, So we are going to check for the first linear inequality. We have y is less than 2x plus 2. So we need to choose points from below and above. For the below, for the first graph, I'm gonna choose 1 and 1. And for the above, I'm gonna choose negative 1 and 4. 1 and 1, negative 1 and 4. For the second inequality, we have y is greater than or equal to 1 half, negative 1 half x plus 1 half. Or we can just use the original for the given inequalities. So this is y is less than 2x plus 2, and the other one is 2x plus 4y is greater than or equal to 2. So for the below, I'm gonna choose 1 and negative 1, 1 and negative 1, and for the above, I'm gonna choose positive 2 and 2. Okay, substitute the values of x and y in your linear inequalities. So our y is 1, 2 times 1 plus 2, 1 is less than 2 plus 2, 1 is less than 4, and this is true. For the above, we have here y and 2x plus 2, negative 1 is less than 2 times 4. No. This is incorrect. Our y is 4. So 4 is less than 2 times negative 1 plus 2. 4 is less than negative 2 plus 2. Y is, this is false. 4 is greater than, less than 0. So this is false. So for the first graph, we are going to shade below. So here, we are going to shade the below part here. For the second one, we are going to solve this. 2x plus 4y equal to 2. This is 2 times 1 plus 4 times negative 1 greater than or equal to 2. 2 minus 4 is greater than or equal to 2. Negative 2 is greater than or equal to 2. And this is false. For the above, this is 2x plus 4y is greater than or equal to 2. 2 times 2 plus 4 times 2 equal to 2. 4 plus 8 is greater than or equal to 2. This is 12 is greater than to 2, and this is true. So for the second, we are going to shade the above part. So this is our above part. Okay. Now this is now our shaded region, or the double shaded region, which contains the solutions for the inequalities y is less than 2x plus 2 and 2x plus 4y is greater than or equal to 2. Now let's check. Let's have a test point. We're only gonna choose one. Let's check positive 3 and 3 here. This is located on the double shaded region. So positive 3 and 3. Let's solve for the two linear inequalities for our system if we made the correct decision in shading the double shaded region. So this is x, this is y. So 3 is less than 2 times 3 plus 2. 3 less than 6 plus 2, 3 is less than 8, and this is very much true. For the second one, we have 2 times 3 plus 4 times 3 is greater than or equal to 2. We have 6 plus 12 is greater than or equal to 2, and this is 18 equal to 2, and this is also very much true. So therefore, our graph is correct.
Now let us proceed to quiz time. Let us test how you understand or if you have understood the topic. So we have here the directions. Graph the given system of linear inequalities in two variables using the same steps in the example or the activity that we had. Write your answer on a separate sheet of graphing paper. So this is your system of linear inequalities in two variables. We have 2x plus y is greater than 3 and y is less than 5 minus 2x. Now after doing this one, let's do another activity. Same instructions, graph the given system of linear inequalities in two variables using the same steps in the examples. Write your answer on a separate sheet of graphing paper. And you have here the systems of linear inequalities in two variables. We have here 2x plus 3y is greater than 6, x is less than 0, and y is greater than or equal to 4. And that ends our discussion. See you on our next meeting.